Hi guys, hello. Hey everyone, how are you all? Good morning everyone. Okay, so you all, if you are able to hear me, if you are able to see me, just write you in the chat box. Okay, so when I'm looking in this direction, by the way, I'm just reading the chat box. You know the drill. This is where the laptop and the camera is, and I just want to know how many of you are here and how is the Josh. That's what also I want to know. Yes, yes. Good morning, everyone. Good morning. Who all are here? I can see that Bhanu, Pulkit, Hema, Marshmallow, Arushi, Tripali, Dev Chauhan, Ghanshyam, Bhanu, Shankha, Harry, Pulkit, Smart Sanjeev. I have now started remembering the names by the way. मुझे बहुत सारे नाम अब familiar लगने लगे हैं. Okay, good to have you all so regularly in the classes. Okay, that's one of the good signs of preparing for any examination, be it your board exam, be it a competitive examination. If you are regular in a class, then certainly you are bound to get the benefits. Yes or no? Okay, so I'm hoping that all of you are doing well and not going out, staying at home, keeping yourself safe. Okay, so don't worry about your preparations. You are aware that at Vedantu you are preparing for your JEE examination. We all are meeting every day for physics, chemistry, and mathematics. So we are back with another series, as I told you, people. For people who are preparing for JEE for this year, we have come up with something which is even more customized, and that we call as the doubt destroying sessions. Okay, don't know about the corona, but we can certainly destroy the doubts that we have in physics. Okay, so today's session is going to be about rotation for people who are here for the first time in my session. This is me, your Suri sir, also known as Mugambo. Okay, why am I called that is because when you'll be cracking the examination of JEE, then yes, Mugambo khush hoga. Okay, guys. Awesome, awesome. Good to have you all. So, as I told you, people, you don't have to go out. Just be at your home and in the safe atmosphere of your home, in the reduced atmosphere with respect to the risk. You can study at the convenience of your house without going out. You can, not to uh, worry about your studies. I would rather put it this way: the learning won't stop and our studies will continue. Okay. So, guys, if yes, there is one more information that I wanted to share with you all, that Vedantu app, at which now the entire content is free for every student who's studying, ranging from class 1 to class 12, be it any competitive examination also. All the content is available for everybody. And thank you so much for all of you to utilize this app, because the app is only and only for you guys. The app has crossed 5 million plus downloads on the Play Store. Okay, guys, so if you haven't downloaded the app yet, अगर अभी तक भी app download नहीं किया है, तो go on the Play Store, download the app, and take the advantage of all the content, teaching, video, and study material which is available on this app. Okay, cool guys. And as far as the YouTube channel is concerned, अगर अभी तक subscribe नहीं किया है, so do subscribe to the channel. Reason being, we are doing amazing things here. We are trying to crack this examination of JEE, and I'm sure we all will. For that, you don't want to miss out on any of the opportunities as well as the notifications which are being done over here. So just subscribe to the channel and stay tuned for all the updates as well as the teaching material motivation session that is done here. Okay, awesome, awesome. So what exactly have we done here? Doubt destroying sessions are basically, if you'll go on the community page of the channel, which is on YouTube itself, you will find every day a topic being floated for which you can ask your doubts. That doubt gets, you know, there is a Google form on which you can enter your doubts, and when you enter those doubts get restored or get stored in a repository, and in that repository we are able to see your doubts. And I have brought all maximum number of doubts. In fact, I would rather put it this way, because with respect to rotation, motion, all the doubts which were there, I've handpicked all of them, and the content today is nothing but all the doubts which students have asked over here. Okay, so maybe you were not aware about it. You can go to the community page. I'm sure you guys are aware about the community page of every channel. So on the community page, you will find the link of the next session which is going to happen. For that, you can ask your doubt for a particular chapter. Okay, guys. So if we speak about today's session, as I said, today's session is about rotation. Okay, so let's start. So this is the very first doubt. Okay, yeah. So doubt says that this is basically a doubt being asked by Sandeepan from Kolkata. So hi Sandeepan, I hope that you are watching us live. This is your doubt that I'm reading. How to generally approach questions from this chapter? This is one of my weak topics. Please tell me some important concepts of rotation which I should learn. Now this is a holistic question actually. Okay. So I know that rotation is one of those topics which many students find difficult. And when I was a student like you people, I used to find it challenging as well. Reason being, whatever you have studied in mechanics before rotation, ranging from kinematics, laws of motion, work per energy, center of mass, and collision, all the concepts that you have studied before this chapter, everything is applicable here, and a single question can test your understanding of all the concepts that you have learned before that. And that is why rotation becomes a very important, very favorite for JEE, and a challenging chapter in itself. Okay, so if I have to tell you how to approach questions from this chapter, then that's a very, very, very question centric uh, problem centric question, rather I should say question centric question or problem centric question it is, as we are going to solve a lot of questions today as well, and I'll teach you a lot of concepts as well based upon the doubts which are being asked. So you will get to know that how do we approach questions. In general, if I put it this way, that in physics, if you have to solve questions, then I have given this advice earlier as well. There are two basic fundamentals that I share with students. One thing is that your um, imagination and visualization is very important when you are learning physics. Okay, means what? When you are reading any question, you should be able to close your eyes. As no, you will be able to close your eyes, but when you are able to close your eyes, then you should be able to visualize what is happening in the question. Okay, you should be able to read the question and simultaneously be able to visualize what it will look like in the real life. Okay, that's one thing. Second thing is your own curiosity towards that topic is becomes very, very, very essential, because if you are curious about that particular chapter, that particular situation, then you will naturally drive your imagination and your own knowledge in that particular direction. Okay, so if I speak with respect to general approach to a question, yes, the general approach will depend upon the problem, will depend upon the formulas as well as the concepts that you have learned in that. Okay, so now if we if I still have to tell you that how do you approach this chapter of rotation, then in rotation motion, guys, the things that you should know. First thing that you should know is basically the angular kinematics. Angular kinematics, which means what? All the equations of motion is what you should know. Means if the body is uniformly rotating, if the body is uniformly accelerating, if the body is non-uniformly accelerating, so all the equations that you have learned before in the chapter of kinematics can be used in the form of angular motion. Okay, like if I have to tell you, if the body is angularly accelerating, then the equations like omega equal to omega naught plus alpha t. Similarly, theta equal to omega naught t plus half alpha t square, and omega square equal to omega naught square plus 2 alpha theta. These are the equations which you can use whenever the chapter question is giving you concepts of angular acceleration being constant. Okay, people are asking why and how can you ask these questions, so I have given you the details. You can go on the community page of the channel. On the community page, every day we will find a particular chapter uh, Google Sheet being shared. On that Google Sheet, you can post your doubts. They will be stored in a repository. So this was done yesterday, and I think day before as well. So that is where you had a window. So be very regular on the channel. That's basically the point here. Okay, coming back. So apart from rotation, obviously, apart from angular kinematics, the heart of the chapter will revolve around the concept of torque. उसके अलावा हमें क्या क्या मालूम होना चाहिए? We should know rotational kinetic energy, and we should know angular momentum and its conservation also. Conservation of angular momentum and the concept of rolling. These are the concepts that you should go through very thoroughly when you are starting this chapter. Okay, Sandeepan, I hope I have given you a idea what are the topics that you should be focusing upon in this particular chapter. Okay, cool guys. So this was our first doubt. More than problems or related to a concept, it was more of a holistic doubt. Okay. Now, next is being asked by Christine from Kottayam and Rohan Singhvi from Hyderabad. These are the two guys who have asked questions which are of the same category. Christine asks, explain concept of torque. And Rohan का doubt है, is it possible to have rotational motion without torque? So first I'll start answering from Rohan's question. Okay guys, I hope you all are listening. Okay. So when you have any object which has to move in a straight line, if I speak from laws of motion point of view, you know that this body cannot start moving unless there is an external force acting on it. Yes, we know this as the first law of motion. A body will remain at rest until and unless there is an external unbalanced force applied on it. Similarly, if a body is at rest and has a possibility of rotation, just think of the door in any of the rooms of your house. That door will not rotate unless there is a force being applied on it. And how the force has to apply? It has to apply in such a way that it can turn the body. So if I straightforwardly answer your question now, that is it possible to have rotation motion without torque? No. Rotation, the reason behind the rotation motion or the cause of rotation motion is basically torque. So rotation motion is not possible unless there is a torque acting on the body. Okay? Yes. It's called as the turning effect of force. Now, coming to how the torque is applied, how it works, the diagram is quite helpful here, I think. Okay. So what you see here, guys, this basically is the axis of rotation. What is AOR? Repeating again, AOR is basically axis of rotation about which the body is supposed to rotate. Now, this is basically a rod and the body's other part is connected here. So what you are doing basically, you are going to apply a force over here on the body so that the body can move in a kind of a circular path. This point can move in a circular path like this. So we say that the torque is basically given by the formula as R cross F, which we say is basically the cross product of R and F. Now what exactly is R here, guys? R is basically what you see, the distance of the point of application of force, let's call this point as P, from the point where axis of rotation is passing, means gap between O and P. A vector starting from O till P is basically what we call as the position vector, or you can say the R vector. Okay, remember it is not F cross R, it is R cross F. Do not take R as radius, means not always R is going to be radius. Please remember that. Okay. So R is not necessarily a radius vector, it is more of a position vector. The point where the force is acting, the distance of that point from the axis of rotation is what we call as R vector. And in terms of magnitude, I know that you are aware about the cross product, it's nothing but torque is equal to going to be Rf sine theta. Okay guys, what is R? Please remember, not radius but distance of point O and P, or you can say a vector starting from O to P. In simple words, it's called position vector. Okay, next one guys. Next question is being asked by Sagar from Chennai. I hope all of you are live and listening. Sir, can you explain angular momentum and how it is calculated or how to calculate it? So, as I told you people just now before this, that turning effect of force is what we call as torque. Similar lines pe, we can say that turning effect of momentum, or which momentum? Linear momentum, is angular momentum. Okay, guys, this is the bookish definition, that turning effect of momentum is angular momentum. Now, first of all, the story has to start from the understanding of linear momentum or the momentum in general. We say that whenever there is a body which is moving, there are possibilities of two bodies which are moving with the same velocity, but they will not require the same amount of efforts to make them move. For example, listen to me very carefully, guys, here. If I speak about two bodies, say one body is this big and the other body is much bigger than that. And when I say bigger, directly proportional to the mass. Say this body is moving with a velocity of 10 meters per second, and this body is also moving with a speed of 10 meters per second. Just for your understanding, let's say that that first body is basically a car and second body is basically a truck. So a truck and a car are moving with the same velocity 10 meter per second. Do you think the efforts which are being put by the engine of the car and the truck are same? I don't think so. Or rather, put yourself behind the car, put yourself behind the truck, and you have to push the car and truck. To make the car move and to make the truck move, do you think same number of people will be required for the car as it will be required for the truck? Obviously, the answer is no. Car will require lesser people and truck will require more people. That simply means what? If you are able to make them move with the same velocity, just giving you an example, if you are able to make them move with the same velocity, then the amount of motion which they possess is not only the function of their velocity. Amount of motion means what? Amount of efforts which were required to generate that motion. The amount of motion, the content of motion which is possessed by the body is what we call as the momentum. Again, writing it here, what exactly is momentum, just for documentation purpose. Momentum is nothing but content of motion. This is something that I can only make you realize, make you feel that what exactly is content of motion. It is not something which you can experience like that. Okay, so we say that the mass of the object is very important. So content of motion is not only the function of velocity, but it is a function of mass and velocity both. So the product of mass and velocity is basically what gives you the content of motion. I hope that the point is clear. Okay, right? I hope you are able to understand that two objects which have same velocity, the efforts which are required to give them the same velocity are not same. That simply means the amount of motion content which is given to them, the amount of efforts are directly proportional to the amount of content of motion which is given to the object, is basically what we are trying to say is not only the function of velocity but also is the function of mass. Okay, so we are simply in very simple words saying that what is momentum? Momentum is basically the content of motion possessed by a body. So what exactly is angular momentum? Simply, whenever a body is now going to rotate, so the amount of rotational motion which is possessed by the body, the content of rotational motion that is possessed by the body is basically what we call as the angular momentum. Okay, जितना भी मोमेंट, जितना भी मोशन बॉडी में है, उस मोशन को स्टार्ट करने के लिए, उस मोशन को रोकने के लिए जो एफर्ट्स लगने वाले हैं, वो अमाउंट ऑफ मोशन is basically what we call as the angular momentum. In the case of linear motion, that is called as linear momentum. Now how do we calculate that, guys? As I told you people in the previous slide, only torque calculate करने का method क्या है? R cross F. Angular momentum calculate करने के लिए you will go by the method R cross P, which simply means what? Again, there is axis of rotation. What you see here, this line that you are seeing is again axis of rotation. So a body is moving in this path. Okay, say for the body which is moving in a circular path, this is basically the radius also, or you can say the r vector, the distance of the body from the axis of rotation. So for that particular body which is moving at a given point with a velocity v, जो linear momentum है, that will be given by m into v. This is basically p. Okay. So how do I write the angular momentum? We'll come to the direction part of it. Don't worry. I'll come to the direction part also. Okay. So the angular momentum is r cross p. P you can write as r cross v. So overall your angular momentum for a body which is moving in a circular path. This is for a body which is moving in a circular path, comes out to be mvr sine theta. Okay, you can write it as mvr sine theta, the moment, the overall magnitude of the angular momentum. Okay, but if you are dealing with a rigid body, okay, this was basically the circular path of a point mass. But if you are dealing with a rigid body, then the formula will be written as I omega. जैसे लीनियर मोमेंटम को हम लिखते हैं एज m into v, एंगुलर मोमेंटम हो जाएगा I into omega. Okay, I just want to go back a bit to give you guys another idea here. Just using this space, whatever is the role of linear motion में, whatever is the role of displacement will be played by theta, angular displacement. Whatever was velocity will become angular velocity. Whatever is acceleration becomes angular acceleration. Whatever was the role of force becomes the role of torque. What used to be your mass, the role will be played by moment of inertia now. And what used to be linear momentum will become angular momentum. Okay guys, remember these points. So if your momentum is mass into velocity, angular momentum will be I into omega, because mass का counterpart is moment of inertia, velocity का counterpart is angular velocity. Okay, so that's what is happening. So remember very carefully, if the body is moving in a circular path, that means we are talking about a point mass. For your understanding, listen to me very carefully. Okay, I know that you guys have a lot of questions which you want to ask on the chat box as well, but listen to this part. Stop right now for a moment. Stop writing anything on the chat box. Listen to me carefully, guys. When do I use the formula mvr or mvr sine theta, and when do I use the formula I omega? For this, I'm giving you an example. So listen to me carefully. Okay. So if I consider the example of Earth, when Earth is revolving around Sun, assuming that Earth is moving in around Sun in a circular orbit, assuming. So, comparative to the radius of the circular path, you know that the size of the Earth is very small, right? So, we will consider that Earth is a point mass for its revolution around Sun. I hope the point is clear, okay? So, there we consider Earth's motion not rotational, rather it is circular motion. So, for circular motion, if you have to calculate the angular momentum, you will calculate it by the formula of mvr sine theta, where m is the mass of Earth, v is the speed of the Earth, and r is the radius of the circular path. Theta is the angle between r vector and v vector. Okay, clear? But if I consider the same Earth and its rotation about its own axis, you know that Earth is rotating about its own axis as well, because of which day and night happen. So if I consider the rotation of Earth about its own axis, then you consider Earth not as a point mass, but as a rigid body, a body which is very big, right? So in that case, what you will calculate angular momentum as? You will calculate it as the product of moment of inertia of Earth and the angular velocity of the Earth about its own rotation. Okay? Understood? Similarly, यहीं पे बता देते हैं, if we speak about the conservation of angular momentum, for that the torque acting on the body should be 0. The torque is given as dl by dt, which is equal to I alpha, going on the same lines of F is equal to dp by dt and F is equal to ma. So if torque becomes 0, then the angular momentum will be conserved. Like in linear motion, if the external force acting on the body becomes 0, the not just the body but the system, if the external force acting on the system becomes 0, the momentum of the system remains conserved or constant. Similarly here also, if the external torque acting on the body becomes 0, then the torque will result in angular momentum not changing, becoming constant. Okay guys, I hope you are able to follow now. Okay, if torque is 0. If. Okay, next one guys, read the question. So comes the question, sir, what is the direction of angular quantities like torque, angular acceleration, angular velocity, angular momentum, every angular quantity? Okay, this is the question which is asked by Omkar from Raipur. Okay, so Omkar, I hope that you are listening. For any angular quantity, all you have to do is use your right hand. Okay, use your right hand, curl your fingers along the direction of rotation motion. That means what? If you see from the top, if you find the body to be moving, say in anti-clockwise direction, so take your right hand, curl your fingers in that direction, and when you are curling your fingers in that direction, okay, so when you are curling your fingers in that direction, okay, so what you are seeing here, this is what is happening, okay, right? This is how the rotation is happening. So in that case, the thumb will come out towards you, okay? So that will basically give you the direction of the angular quantity. Similarly, if you are talking about a clockwise direction, then again take your right hand. Right now, do that, guys. जिस तरह से यहाँ पे मैंने direction दिया है, just take your right hand and curl your fingers in that direction. Okay. So what you see here, I'm using my right hand. I'm curling my fingers. Okay. You can see that the thumb is pointing towards me. That means if you are doing it, the thumb will point towards you. In that case, the thumb is basically the vector or the direction of your angular quantity. All you have to do is use your right hand. This is called right hand thumb rule. So the answer to this question is right hand thumb rule, RHTR. Whatever is the sense of rotation, just curl your fingers in that direction of right hand. Thumb will give you the direction of angular velocity, angular displacement, torque, angular momentum, and acceleration. Okay. We'll come to the toppling also, don't worry. Okay. Now this one. Question is being asked by Srushti Paul from Pune and Atharva from Kota. Okay. Is the impulse momentum equation, so first one is, what is the linear and angular impulse? Sorry, I forgot to read that. What is linear and angular impulse? That's the first question. Second one says, is the impulse momentum equation necessary to be written about the point of application of impulse, just like in angular momentum conservation, or it can be written about any point like center of mass? So first of all, what exactly is impulse? I'm sure you guys are aware about it. Impulse is basically, if I speak with respect to linear impulse is simply a force which is acting for a very short duration of time. Means what? If I have to give you this example, guys, say if you are driving a car, or if you are driving your own two-wheeler, if you are driving a two-wheeler and say you see that the signal is now red and you are already half a kilometer or 200-300 meters behind. Okay, you are going on the road, 100-200 meters before the signal, you see that the signal has become red, so you apply the brake. You easily apply the brake and you slowly and steadily decrease your velocity, so that by the time you reach the signal, your vehicle stops, right? The amount of change of your momentum is basically the change of velocity multiplied by the mass, or rather, let me put it this way. Say your vehicle had a velocity of 20 meters per second, and finally you want to make it 0. Okay, so in the first example that I'm giving you, that you see that you have around 200 meters of distance, and say you take 10 seconds to stop easily, or say 5 seconds you take to stop. You cover this 200 meter to bring your velocity down from 20 meter per second to 0. I hope that you guys are following. Okay, there is a vehicle that you are driving which is moving at speed of 20 meters per second. You see a signal, you are 200 meters behind that signal, you apply the brake, you take 5 seconds and you stop. So if I look at this, the momentum is changing by the same amount, the mass of the car into 20 meters per second. But in the second case, when you look at the signal being red, you are only say 5 meters away from it. So you suddenly apply the brake. And when you suddenly apply the brake, now you take only 0.5 second to stop. Are you getting it? You were trying to cross the signal, but suddenly signal became red and you applied the brake. So you suddenly stop. Within 1 second you stop. So in both the cases, your car or your vehicle is stopping from 20 meter per second, the velocity is becoming zero. Yes. But the amount of shock that you will feel, the amount of shock that you will feel is going to be more in the second case. You know that, right? The amount of shock, the jerk that you will be more in the second case. So what I'm trying to tell you guys, the impulse is basically the quantity which is defined as the force which is acting for a very short duration of time. The shorter be the duration, more be the force that will act on your body. Why is it so? Is because the force which acts on our body is equal to the change in momentum upon change in time. So maybe the change in momentum is same for both the cases, but it is inversely proportional to the change in time, and the time is less in the second case. So the force will be more. I hope you guys are getting. So if the force is more, yes, the impulse will be more over there. Okay. I hope the point is clear. Impulse is basically a force which is acting for a very short duration of time. Now take the same thing and think about rotation motion. Means what? Just think of the ceiling fan in your house. Just think of a ceiling fan in your house right now. Say it is switched off. The ceiling fan which is there. If you switch it on, it takes its own sweet time to increase its velocity. Slowly and steadily it increases the speed and then starts moving faster, right? But say that the fan which is stopped there, you hit one of the blade very strongly like this. So if you hit it very strongly, suddenly it will start gaining some velocity. For some time it will gain, obviously. So the amount of sudden force that you are applying on it, the force which you are applying for a very short duration of time will basically give it a shock. So in the case of that, it will start rotating. So that will be called as the angular impulse. So if the force is generating linear motion, then that will be angular impulse. And if the force is generating rotation motion, that will be called the angular impulse. So if I go by definition, the force acting for a very short duration of time is basically your impulse. Also, technically it is equal to the change in momentum. Magnitude is only equal to change in momentum. But in the case of angular impulse, that will be torque acting for a very short duration of time and will be understood as change in angular momentum. Okay? Yep. So, next one, guys. Now comes the part where maximum doubts have come. Just read the questions. So the question says, first one is being asked by Ronit Gupta from Pune. So Ronit's doubt is, can you explain the concept of rolling, toppling, and sliding? I'm sure that's the hot topic for today. We'll come to that for sure. Next one says, Mugambo sir, combined rotation or translation motion, that is CRTM, combined rotation and translation motion के बारे में कुछ बताओ. जरूर बताएंगे विजय. Okay, Vijay is from Bangalore. Next one, toppling. Please discuss about it for a while. We'll discuss it in length and breadth. Okay, Srihari from Udupi. Next one is being asked by Kushal from Hyderabad. He says that in rolling, we say that the point in contact with the fixed frame of reference is in rest. When the body is rotating, the bottommost point is in rest. But we see that the point changes its position continuously. So what exactly is happening? He wants to understand that. Similar concept doubts. Anmol Tiwari from Delhi says, sir, explain direction of friction during combined translation and rotation motion or simply rolling. Hi Mugambo sir, I have a doubt about judging the direction of friction while doing the CRTM problems. Like a ring, its direction interchanges up the center of mass. This is Nimish from Jakhal. Okay, Jakhal. I have never heard about the name of this place, by the way. Where exactly is this? Next one is Shankha from Durgapur. She says that, sir, in pure rolling, it is always applicable that the point which is in contact with the ground always remains in rest. Okay. Yes, it is applicable, by the way. And Anmol Tiwari from Delhi has again asked the question that, sir, toppling and shifting of normal as well. Okay, so as you can see that all the questions which are here are related to the rolling motion, toppling and sliding. Fine. So I will speak about the rolling motion first. Okay, I can see people are joining still. Okay, so if you are here for the first time, welcome. You are in the middle of the session right now. It's a live session, obviously, and these are the doubts that you guys see are the doubts which were posted by students only on the Google form. Google form is available on the community page, again and again repeating. Where exactly you find community page? On YouTube channel, there are different tabs available. So if you go to Vedantu's JE channel, you will find community as the third tab, I guess. Okay. So if you go there, there you will find there is a link which is shared. Just scroll down a bit. You'll find a Google form link being shared along with the name of the chapter. You can post your doubts, and whenever the session happens, you will be notified about that, and you can come and get your doubts being answered. Okay. Okay. So guys, coming to the concept of rolling. Well, first of all, rolling is considered as the combination of pure rotation and pure translation. Okay. Means what? Let's first think about pure rotation, pure translation. So when I say pure translation is basically like a block moving. So what you see here, this point, this point, this point, in fact, any point on this body is moving with the same velocity in the linear direction. So that velocity is say VCOM. Okay, just like a block or a train moving. So every point on the object is moving with the same velocity. Any point, that velocity is say V. Okay, and that is also the velocity of the center of mass. This is pure translation. No rotation happening in that case. Second one is your pure rotation. Pure rotation is basically the way your ceiling fan is rotating right now, right? In which the body is only rotating about its own axis of rotation. So this is how the different points are moving. Tangential velocity. We know that all the points which are there on the tangent are moving with the velocity which is in the tangent direction, or you can say the body itself is having an angular velocity omega. So if I will take these two possible cases and I will overlap them, if you put rotation motion wala image over the translation motion, what will happen is basically what we call as the pure rolling motion. Means what? If you look at point T, you can see that this velocity is along horizontal direction. This is also along the horizontal direction. Both of them are in the same direction vector. So both the same direction vectors will add, and you can see that the velocity becomes double for the topmost point. If you look at the center of mass or the center of the body, here obviously center of mass was not moving, the center was not moving, but here center was moving because it was translation. So when you will take zero velocity, put it over VCOM, the final velocity will become VCOM only. But now the interesting case is the bottommost point here. Okay. In fact, before the bottommost point, let me speak about a point like this. इस point के बारे में भी बात करते हैं. यहाँ पे देखो, this point in the case of rotation is going up. So this is the direction of the body because of the velocity of due to rotation, right? This was the velocity due to rotation. And if I speak about this one, this is the velocity due to translation. दोनों के magnitude same है, both are v. So if I find the resultant, that is basically the direction in which this point is actually trying to go. That is v root 2, and more important is the direction. It is trying to go towards t. If I will take this point, by the way, because of rotation, the linear velocity was coming downward. I hope you are following, guys. And because of translation, the linear velocity is forward. So this is the direction in which the body is actually trying to go, and that is why after some time this point will come down. I hope you are following. Now comes the bottommost point here. Okay, the bottommost point, because of rotation, is trying to go to the left side. Okay, you can see that the direction is towards the left, and because of translation, it is trying to go towards right. So when you will put it here, because of translation, the velocity is towards right. and because of rotation the velocity is towards left, and both have equal magnitude. If both have equal magnitude, rather I should say if this is happening, if your v is equal to omega r, this basically is r, and this v is basically equal to omega r, and this velocity is v. So if v is equal to omega r, if that condition is satisfied, then these two vectors will cancel out each other, and point P, my dear friends, point P will remain at rest. The point which is on the bottommost point will remain at rest. So if your bottommost point remains at rest, and that is the case which is only possible when this condition is satisfied, then we say the type of rolling which is happening as the pure rolling case. Okay, if v is not equal to omega r, then the case is impure rolling. Okay, so when the body is rotating, obviously the bottommost point will keep on changing as the body is going forward, but whichever point will come at the bottom, जो भी point bottom पे आता है, उस point की उस instant पे जो velocity है, that velocity if it is equal to 0, Vp if it is equal to 0, then the body is performing pure rolling motion. If Vp is not 0, then the body is not performing pure rolling, rather it will slip. Okay, it will be slipping, and we'll come to that point also, don't worry. Okay, so point clear. Remember, bottommost point, if it is at rest for an instant, obviously, because that point is going to go forward, थोड़ी देर के बाद में bottommost point जो है वो यहाँ आ जाएगा, फिर यहाँ चला जाएगा, bottommost रहेगा ही नहीं, वो point P जो है वो आगे चला जाएगा, right? So whichever point will come at the bottom, that point, if it is at rest for that instant, then the body is performing pure rolling motion. If that point is sliding with respect to ground, then the body is performing impure rolling. Okay guys, fine. Next thing is the concept of toppling and sliding. So one thing that I want to tell you here guys, toppling is basically a type of rotation, right? And sliding is a type of translation. Okay, so if the body has to topple, if your body has to topple, then remember toppling will happen if rotation is greater than translation. Remember this, if the body has to topple, then rotation has to be greater than translation, and if the body has to slide, then translation has to be greater than rotation. Simple words mein. Okay, now if I have to give you the understanding of this thing, say you have this body which is placed on the ground. Okay, so what you do, obviously it's a rough surface, so what you are doing, you are basically trying to apply a force like this on the top. Think of it like a box. ऐसा सोचो कि it's a box, and on this box you are applying the force on the topmost point here. So when you are applying the force on the topmost point here, what will happen? The body will try to move along the direction of the force. So if the friction is available, this friction will try to stop the body from moving, or it will try to do so. But say the body has sufficient amount of friction, means what? If this friction is static, then the body cannot slide, because the body has static friction. Because of the static friction, which simply means that the force is not able to generate the translation motion. So what will happen guys? What you see here, that earlier normal reaction was passing from here. Now what will happen? This is just like having a hindrance at this point. Okay, just think of it like a hindrance which is there just before it, means just like a roadblock. A roadblock is being placed here. ऐसा सोच सकते हो. So about this point, what will happen? Now the body will try to take a turn. Why so? Is because about this point, this force will be able to generate a turning effect. Okay. So what is happening now? After some time, when the toppling starts here, the normal reaction will now pass through this. Why the normal reaction is passing through this? Because normal reaction is basically a contact force. Normal reaction is a contact force. Means what? When your body is not able to slide, it will have a tendency to turn. It will have a tendency to rotate. And during that tendency of rotation, the right end of the body will be under more pressure in comparison to the left end of the body. Means what? If I call this point as A and this point as B, when you are trying to apply the force F, point A will have less stress, point B will have more stress. That is because the body is trying to take a topple, is trying to take a turn over the point A. Means what? For an instant now, the axis of rotation is trying to pass through this particular point. Okay. So now what is happening? Your normal reaction is shifting in this side because from here slowly and steadily the contact is going to be lost. पॉइंट ए से कॉन्टैक्ट चला जाएगा और अब पॉइंट ऑफ कॉन्टैक्ट सिर्फ बी रह जाएगा. तो जहां भी पॉइंट ऑफ कॉन्टैक्ट होगा नॉर्मल फोर्स विल ओनली एक्ट देयर, सो दैट इज व्हाई द नॉर्मल फोर्स हैज shifted over there. And at this particular point what you are able to see that the torque will not be applied by normal or friction, rather will be applied by this force and mg. This force is trying to rotate the body clockwise and mg is trying to rotate the body anti-clockwise. So if this force torque, the torque which is applied in clockwise and torque which is applied in anti-clockwise, if these two are unbalanced, the body will topple. Okay. But in the case of sliding, I told you translation will be more than rotation. The body will simply start moving. So the questions that you solve usually in the case of translation motion means what will happen here? Your normal will be balanced by mg cos theta. And if the body is sliding down, then you will say that mg sin theta minus friction will be equal to mass into acceleration. And you can write friction as mu into n, put the value of n to simplify it. Okay. Just remember this, very important. When will the sliding happen and when will the toppling happen? Okay. Next one. Question is asked by Anmol Sharma from Hamirpur, Himachal Pradesh. Just read the question, guys. Question hai that what is the criteria for using instantaneous axis of rotation? Can we take zero velocity point as the axis of rotation? Can we use energy conservation even when the slipping is acting on motion of object? First, I'll try to answer question number 2. Can we use energy conservation even when slipping is acting on the motion of object? Well, first of all, law of conservation of energy is applicable always. It's a law which says that energy can neither be created nor be destroyed, it can only be transformed. I think what you are trying to ask, Anmol, is that the law of conservation of mechanical energy. You are talking about the mechanical energy, which is potential energy plus kinetic energy. So if the question is can we use law of conservation of mechanical energy when the slipping is happening, then also there are two types of cases. Okay, one case is when friction is not there, the surface is frictionless, and when the surface is rough, that means it has friction. So you know that friction is basically the non-conservative force. If your body is experiencing no friction, then obviously it will have no loss of energy. So you can apply law of conservation of mechanical energy if the body is on frictionless surface. You can apply it on the frictionless surface. But if friction is present, then what will happen? Your mechanical energy will be reduced. It will be converted to heat. So that is where you will not be able to conserve the mechanical energy. Please remember, I am not saying law of conservation of energy is not applicable. Law of conservation of mechanical energy will not be applicable if friction is present. Mechanical energy, because the mechanical energy is converting itself into heat. But overall, in the bigger picture, energy is still conserved. Energy which is mechanical is converting into heat. That's it. Okay. Now coming to the instantaneous axis of rotation. For people who do not know about instantaneous axis of rotation, it's fine. It's not a concept which is a essential concept, but if you know it, sometimes it becomes easier for you to solve a question. So usually when we solve a question of rotation, we consider the axis of rotation is passing through the center of mass, right? But when say instantaneous of axis of rotation has to be considered, this is basically the case usually when we are studying the concept of rolling motion. So in rolling motion, when we are talking about the normal axis of rotation, the body is performing translation and the body is performing rotation. Both the things are happening. As I've told you a few minutes before, that rolling is nothing but translation plus rotation. So about the center of mass, if you are taking the axis of rotation, then translation says that the center of mass has a velocity that is VCM, and rotation says that the center of mass has a velocity, or the body has a velocity that is omega r. So these two velocities both are existing there, right? That is what is basically happening when you are considering the axis of rotation about center of mass. But if, say, for a moment, you start considering the bottommost point, the point which I told you people does not move in the case of pure rolling. This is basically, I'm talking about the pure rolling. Okay. So if I start considering this point as the point of axis of rotation, that means at this particular time, the entire body is basically taking a topple about this particular point. Means what? For a moment, बहुत थोड़ी देर के लिए, the entire body is basically toppling about this point. Means what? About point P, if the axis of rotation is passing, then the body performs pure rotation with the same angular velocity omega. Okay, when the body is taken, the axis of rotation is taken about P. So this time the difference that will come is basically that you will write the velocity of points, different points with different distance. अभी भी velocity को omega r ही लिखेंगे, rather I should say omega into small r ही लिखेंगे, but small r का value will keep on changing. Like if you will look at this point, center of mass, you can see that it is at a distance r. Now the entire body is taking a topple with an angular velocity omega. It's toppling. So you can see that this green vector has a velocity VCM, while this other green vector, which is at a distance 2r, you can see that point A, this is point O. I think I'll be able to explain it here better. Let's call this point O. Let's call this point as T. This point as T. Okay. So you can see that OP का distance जो है वो R है और OT का distance 2R है. So if you look at the velocity of O, that velocity is omega into R. But if I speak about velocity of point T, the velocity is now V equal to omega R, but the R value is R plus R, that is 2R. So this is 2 omega R. So simply velocity of T is 2 times the velocity of O, right? So what is happening? Now the entire body is taking a topple. So this point is also rotating like this point is also rotating like this point is also rotating. No translation is considered when you consider this point as instantaneous axis of rotation. Word instantaneous is very important because point P after some time will not be here, it will move somewhere here. So a new point will come at the bottom. So that point for an instant will behave as the axis of rotation. So when you are considering instantaneous axis of rotation for a very small duration of time, you can consider the body is just toppling, right? So what you were writing earlier when the body was purely rolling as the energy, you were writing the energy as half I omega square plus half mv square. This is energy due to rotation. This is energy due to kinetic energy due to translation. This I is basically about the center of mass, IC. But now I'm saying that because the energy will remain conserved, now you can consider this energy to be just the pure rotation kinetic energy, which is half I omega square. But now the I value, moment of inertia, will be considered about point P. Will be considered about P. Okay. Please remember what I'm writing here. The important difference is the moment of inertia. The moment of inertia about O will be different, about P will be different. Okay, so that is where the value of energy of I omega square here and I omega square here will come out to be different. I hope the point is clear. When do I have to use the instantaneous axis of rotation? When pure rolling case, has no linear velocity being given, or when I want to solve the question, when I want to visualize the question just as a pure rotation case. So for an instant, the body is purely rotating about the instantaneous axis. Okay. Now this one, guys, now it's a numerical question being asked by Santosh from Hyderabad. So what does he say? He has asked the question that there is a sphere of mass m, radius is r, it is moving on a rough surface of coefficient of friction mu. It will attain a minimum linear velocity after a time interval of how much? Okay. So first of all, it is already moving with a velocity v naught, and this is omega naught, and right now v naught is greater than omega naught r, means impure rolling is happening. This is called impure rolling. So when impure rolling is happening and velocity has to become minimum, that means velocity has to reduce. So for velocity to reduce, a backward force has to act on it. And this backward force is basically the force of friction. Okay. Say the mass of the body is given as m and its radius is given as r. So this linear motion force, that is friction force, which is equal to mu into mg, is going to be equal to its mass into acceleration. So from here the acceleration, or rather this is the retardation, comes out to be mu g. Yeah, you can see that F equal to ma lagaya, equation of translation. So we can say that the new final velocity v will be equal to v naught minus at. Okay, minus q lagaya because this is retardation. Okay, so v equal to v naught minus at tells you v equal to v naught minus mu into g into t. That's our first equation. Final velocity which we are looking for, the final minimum velocity. Okay, minimum velocity कब होगी? जब body purely rotate करने लगेगी, जब pure translation होने लगेगा. If I speak with respect to rotation, means this was force, now I'll write torque. Torque which is equal to I alpha. So torque is applied as F cross R, दोनों के बीच में angle 90 degree है, should be equal to I alpha. So I into alpha. So friction is mu into mg into r. Moment of inertia for a sphere is 2 by 5 mr square into alpha. तो m और एक r cancel हो जाता है. Alpha value comes out to be 5 mu g by 2r. That's what I get as alpha. Okay, guys. Now what? 5 mu g by 2r. So omega will be equal to omega naught plus alpha t. Now why am I writing plus alpha t and not minus alpha t? Is listen, this body is rotating clockwise and the torque which is being generated is also clockwise. The torque which is acting is also clockwise. You can see that, right? The torque which is applied by the friction force, you can look at the direction, the torque is coming out to be clockwise. That's why angular velocity will increase and linear velocity is going to decrease. So the final angular velocity is omega, which we can write as omega naught plus alpha, which is equal to 5 mu g by 2r. So this is 5 mu g by 2r into t. This is omega. This is our equation number 2. So according to the question, v is equal to omega r finally. This is the final linear velocity. This is the final angular velocity. So v was equal to v naught minus mu gt. This was v, okay, from equation number 1. V naught minus mu gt. And omega is here, multiply that by r. So I have omega naught r plus 5 mu g by 2. R get cancelled and I have t left here. Okay. So take this mu gt here and omega naught r here. So I have v naught minus omega naught r equal to 5 by 2 mu gt plus mu into g into t. So this is v naught minus omega naught r equal to 7 by 2 mu gt. That means the time after which this is going to happen. This is the condition that we want. This is what is the desired condition. The body will have minimum velocity when the pure rolling starts. Okay. So time comes out to be v naught minus omega naught r divided by 7 mu g, and in numerator you will have a 2 as well. So that's the answer that we were looking for. Okay. Okay. Next one, a solid sphere is rolling without slipping on a level surface at a constant speed of 2 meter per second. How far can it roll up to 30 degrees ramp before it stops? Okay. So a body is basically rolling. That body which is rolling, okay, the body which is rolling is given as a solid sphere, and after some time it is going to be taken to an inclined plane of angle 30 degree. Okay, because nothing has been mentioned, we'll assume that it will continue to purely roll before it comes to rest, and say it will climb a height of h. This L distance has to be found, and we can see that L is basically L sine 30 is h, so L is going to be h by sine 30 degree, which is basically 2 times of h. So we have to find h, and then we'll have to find out the value of L. So if I use the law of conservation of energy, because nothing has been mentioned, so I'll assume that the body is purely rolling. So here, whatever is the energy of the body, which is totally kinetic, will become purely potential energy here. So kinetic energy is half I omega square plus half mv square, which will convert to mgh. Okay, so half I is solid sphere, so 2 by 5 mr square into omega square, and because it is purely rolling, so I'll say it is v square by r square. Okay, purely rolling is v equal to omega r plus half mv square equal to mgh. So m gets cancelled here, r square get cancelled, and 2 gets cancelled. So I have v square by 5 plus v square by 2 equal to gh. That simply means gh comes out to be 7 by 10 v square. So height comes out to be 7 v square by 10 g, which is 7. V is given to us as 2, so that will be 4 upon 100. So this is 28 by 100 is h. So L, which is equal to 2h, will be equal to 56 by 100, or simply 0.56 meters. That's our answer. So this is the length to which it will go before it stops. Okay. Next one. This is the question. I forgot to take the name of this student. It is Sanjeet from Odisha who asked this question. The next one is Nikhil Raghuvanshi from Khargone. Wow, Khargone is the place in MP which I recently been to. I just crossed that city. I was in Khandwa. Okay. So hi Nikhil. I've been to your city around 3 weeks back. I was there before the lockdown happened. Okay. Next, so the question asked by Nikhil is, can you explain this thing that which will among different bodies, ring, disk, solids, and hollow sphere, will reach down the inclined plane easily? Okay, so let me rephrase the question. Say you have different spheres, body which can roll. They are being placed on the inclined plane, say of inclination theta. Which of these body will reach the bottommost point fastest? Okay, so if I say that the distance covered by a body is going to be ut plus half at square, and u is 0, so you can say that the time which will be taken by a body will come out to be 2s by a in under root, which means t is inversely proportional to root of a. The body which will have maximum acceleration will take the minimum time, and that's basically going to be our body. Okay, so what I'm going to do here, say the forces, if I write, this is mg sine theta, this is mg cos theta, this is normal force, and this is the friction force. So for linear motion, I'll say that mg sine theta minus friction is equal to ma. And for rotation motion, rotation will happen because of friction. So F into R will be equal to I alpha, and alpha will be equal to A by R because pure rolling is considered. So I can say that friction is going to be I A by R square. Okay. and I को भी हम लिख देते हैं mk square, which is in terms of radius of gyration. So mk square by r square into a. ठीक है? The other equation is mg sine theta minus friction is equal to ma. I'm writing this equation one more time here so that we can add these two equations. Friction gets cancelled. I have mg sine theta equal to ma, small m. So ma plus mk square by r square a. So m also is getting cancelled here, guys. So g sine theta equal to a taken common. So this becomes g sine theta equal to, if I take a common, I have 1 plus k square by r square. So acceleration comes out to be g sine theta divided by 1 plus k square by r square. So we want a to be minimum. So a will be minimum. We want a to be maximum. For t to be minimum, a should be maximum. Okay, maximum acceleration is what we are looking for. Okay. So for a to be maximum, the denominator has to be minimum. So if I talk about ring, for ring, k square is equal to r square. You know that mk square equal to mr square. For disk, k square is going to be r square by 2. You can just multiply both sides by m, you will get the moment of inertia. For hollow sphere, k square will be equal to 2 by 3 r square, and for solid sphere, k square will be equal to 2 by 5 r square. So this is r square, this is 0.5 r square, this is 0.66 r square, and this is 0.4 r square. So k square by r square turns out to be minimum for solid sphere. This is the minimum value, right? Which means what? Solid sphere will have minimum value of denominator, will have maximum acceleration, and will take minimum time to come to the bottom. That means the answer to the question that was asked, the body which will take the minimum time is basically the body with maximum acceleration, and maximum acceleration के लिए the value of what do you call it? You call it the radius of gyration. Yeah, that word was slipping from my mind. The radius of gyration has to be minimum. Okay, cool guys. Next one, explain the moment of inertia related questions. Please read the question. Saurav, Kavya, Ajay, Shrishti and Shankha have asked the questions which are related to moment of inertia. Okay, and how to apply perpendicular and parallel axis theorem. So you know that moment of inertia is found as the product of mass and the distance of the body from axis of rotation square. So for a particle, this is how we calculate the moment of inertia. For system of particles, we add the moment of inertia because moment of inertia is not a vector quantity. Okay. For a rigid body, we consider it to be made up of small such particles. We write the moment of inertia of each of them as dm into r square, and we add all of them like this. Okay, and that simply means we integrate it. That's how we get the moment of inertia. Okay, when it comes to theorem of perpendicular axis, a body which is going to be a 1D or a 2D body, for that only we apply theorem of perpendicular axis. What you see here, the two axes x and y are in the plane of the body, while z axis is perpendicular to that. So when that is given, the moment of inertia about z axis in the case is equal to ix plus iy. That's basically your theorem of perpendicular axis. Next is your theorem of parallel axis, which is applicable for all the objects, any shape, any object. In this, the moment of inertia about center of mass is to be known. This is something that we should know. And another axis which is shifted parallelly by a distance a, about that we are interested in finding the moment of inertia, that is Iz. So that is given as Iz equal to Icm plus ma square, where m is the mass of the body, a is the distance the distance between the parallel axes. Okay, guys, that's how we think of parallel axis theorem. I'll rather give you an example on how to solve a question based upon the same. So what you see here is basically an object given in this shape. It has these circular sections such that this is also distance a. You can see the radius of this part. So what is given to us that for this lamina, the moment of inertia of the lamina about an axis that is passing through the center of mass and perpendicular to the plane of the body, about this point and perpendicular to the plane, the moment of inertia is given as 1.6 ma square. So we have to find out the moment of inertia about the tangent AB. Okay. So if I'll try to tell you that what exactly is given to you, and trying to draw it about this axis, the moment of inertia is given, that ICM is 1.6 ma square. Okay. So guys, we have to find out the value of moment of inertia about AB. So what is happening here? Drawing it once again so that we can understand what is happening. Okay. So about this point, the moment of inertia is given. This ICM is 1.6 ma square. Okay, yeah, that is 1.6 ma square. And if I consider these two axes which are passing through the plane of the body, we know that they are symmetrical. So if this is I1 and this is I2, then I1 is equal to I2 due to symmetry. Okay, so I say that because I can use perpendicular axis theorem now. So I1 plus I2 will be equal to ICM. Okay, and because both of them are equal, let's write it as 2I1 equal to ICM, that is 1.6 ma square. So I1 ka value comes out to be 0.8 ma square. Okay, now what? You have found the moment of inertia about this axis. This is basically your I1. And now if you will look at this gap, this is A and this is also A. So the two axes are parallelly shifted. So I can say that about this axis, say the moment of inertia is IAB. So I can say that IAB, okay, is basically nothing but ICM, which is right now I1, plus M into D square. So this D is basically 2A. Okay. Now your I1 is basically the axis, the moment of inertia about axis that is passing through the center of mass. This one was perpendicular, this one is passing along the diameter, or you can say the diagonal. So I1 is 0.8 ma square plus m into 2a ka square. So this is 4 ma square and 0.8. So this is 4.8 ma square is what you get finally as the answer. Okay, guys, I hope you got it. Okay, now this one, in this this is the question which was asked by Dev Chauhan from Virar in Mumbai. 2 point masses 0.3 and 0.7 kgs are given. I'll just explain the question to you people. And the body is rotating about this axis. It is made to rotate about this axis with a constant angular velocity omega. So question says that what is the work required to rotate the body? We have to find out the distance x for which the work which is required to make the rod rotate to be minimum. Means we want the value of x for which work done is minimum. Okay, we know that whatever work will be done, okay, that work done is going to be the change in kinetic energy, and that is basically half I omega square. Okay, so because omega is given to you as constant, that value has to remain a constant. So when work has to be minimum, then moment of inertia should also be minimum. Okay, so if I try to write the moment of inertia, guys, moment of inertia is going to be mr square. So 0.3 into x square because इसका distance x है, और दूसरा mass है 0.7, उसका distance हो गया 1.4 minus x square. The length of the rod is 1.4 meters, and this omega I has to be minimum. Okay, this I has to be minimum. So what is the value of I that we wrote? 0.3 x square plus 0.7, 1.4 minus x square. So for I to become minimum, we know that di by dx should become 0. So this is going to be 0.6x plus 1.4 into 1.4 minus x, or x ka differentiation will come out to be minus 1. This should be equal to 0. That means what? I have 0.6x equal to 1.4 into 1.4 minus x. Basically we have taken it to the right hand side. So simplify करते हैं, x पता लगाते हैं. So 1.4 into 1.4 is 1.96 minus 1.4x. Bring it here, you will have 2x equal to 1.96. X comes out to be 0.98 meters. That too from 3 kg body, 0.3 kg body. Okay. So the value of x was to be found in this question. So what we are getting from this body, it has to be 0.98 meters. Okay guys, so this brings us towards the end of the session. Already I read a few comments where people were talking about the crash course. If you are interested in coming for our crash course, guys, all you have to do is come to this link. Okay, what you see here is the link, and if you want to understand what exactly is the offerings here, first of all, the crash course is starting from today itself. Another round of crash course has started. It is going to have 90 live classes for all of you, 20 plus comprehensive tests, ample doubt solving, and yes, you can watch your replays and recordings of the classes that you miss as well. Okay, many more features like that. So all you have to do is follow this link which is available in the description of the video. Don't forget to use the coupon code, because using this coupon code will make the course which is worth rupees 30,000 to come to you for just under 6,000 rupees. Okay guys, these are the steps to be followed. Don't forget to use the coupon code, that is SMCC. Okay, the link is available in the description. Cool guys. So I hope that you guys enjoyed the session. I hope that people whose doubts were asked, they were there. If you want your doubts to be asked, your doubts to be discussed here, I'm again and again repeating, people, go to the community page of the channel. Okay, of our channel. On this channel, go to the community page. You will find scroll down, you will find a link, or you will find a post over there which will mention the topic name, the chapter name, where you have to click, put your questions. Those questions is what we are going to discuss. Okay, so if you guys enjoyed the session, do hit that like button which is over there. Tell your friends also, share that page with them so that they can also ask their doubts. और अगर अभी तक सब्सक्राइब नहीं किया है तो do subscribe to the channel so that you don't miss out on the question that you want to ask. Okay, just one mantra that we are following right now is that learning won't stop. Even when we are not able to go out, our learning won't stop. Okay guys, I hope you guys had fun with me. Okay, do post your comments. How did you like the session? And if you want your doubts to be discussed, again and again repeating, go to the community page, go to the link, put your doubts there. I'll come back with the doubts related to physics. Similarly, Arvind sir is discussing the doubts related to mathematics. Harsh sir is discussing doubts related to chemistry. Yesterday you had a chemistry session with Harsh sir. Day before you had a math session on vectors with Arvind sir. So similarly, this loop will continue, and I'll see you again. Till then, keep studying, and more importantly, stay safe. Okay, cool guys, take care, bye bye.